So right now we are preparing our pH meter. So first what we're going to do is we're going to press sensor on LabQuest. Then we are going to precisely pick calibrate, then CH1:pH. And then we're going to click calibrate now. And now we're going to dip our stir rod into the buffer number 4. And we're going to let it sit there until the voltage stabilizes. And then once it's stabilized, here it says 2.44 V. We're going to press 4.0 as the value for the buffer, and then press keep. Okay. Rod into the distilled water to rinse off the rod. Then gently pat your stir rod. After that is done, place it into the buffer number 7. And once again, let the voltage stabilize. So right now it's 1.69 V. So I put in 7.00 and I press keep. After preparing our stir rod, we're going to gently pat off the stir rod and then place it in our first solution, which is the tap water. After it stabilizes on the LabQuest, we're going to record the pH. So in between checking the pH of different solutions, make sure that we're rinsing our pH meter and the sensor, or excuse me, the pH sensor with the distilled water and gently tapping the excess water off before adding it into our next solution. So adding this into the orange juice and waiting for the pH meter to steady out before recording the actual pH. So the pH meter is giving us a reading for the orange juice at 4.15. This means that pH of 4 is going to be a weak acid, which makes sense considering that orange juice contains acetic acid. Now the difference between a weak acid and a strong acid is that the weak acid is going to only partially ionize in water, whereas a strong acid completely dissociates into its ions of water. Now this allows for chemical equilibrium with a weak acid because it's not completely ionizing into like its ions in the weak acid. So it's allowing a back reaction to happen. It's completely ionizing into H plus water. So there's no way that there could be a back reaction, therefore there's no chemical equilibrium. Right now I'm taking my pH probe and I'm wiping the excess water off of it before I stick it into the apple juice. Once I set it in the apple juice, once you set it in the apple juice, I'm waiting for it to stabilize to get my pH value. For the apple juice would be 3.90. A buffery solution that resists changing in pH when a small amount of acid or base is added. If a pH is lower than 7, it's more acidic. If a pH is higher than 7, it's more basic. So 2 would be a strong acid and 12 would be a strong base.
First, I will remove the probe from the distilled water and gently top it off on a paper towel. And then I will place it in the hydrochloric acid and wait for the meter to stabilize. So the pH of hydrochloric acid is 1.26, and now I will record it in the notebook.